In this example, Bernando has worked in a restaurant and saved 125,500, and he has put that saving into a saving account that gives him 9.25% interest rate compounded monthly. Now he doesn't want to work, and what he wants to do is he wants to use all his saving, enjoy life without working. So for that reason, he wants to withdraw 1,350 each month at the beginning of the month. If he does that, how long does this money last? That's what the question is asking. Let's put this information into a timeline. So the timeline here is like starting from 0, current period, and here is a 1, 2, 3, and I would say dot 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 to n. So he has at the beginning 125,500, right? What he wants to do is we wants to withdraw 1350 at the beginning of each month, right? 1350. He keeps on withdrawing that, and he will keep on withdrawing this until all of his saving is out. So at the end of the saving period, withdrawing period, the saving will be 0. And the interest rate here, the rate or interest rate he is making here, R, equals to 9.25%. So given this information, and this is the present value he has, meaning 125,500, that's the present value of his total saving, and he is gonna withdraw that PMT, this 1350 each month for as long as it is possible, and by the end of this period his saving is all gone, so that 0 will be the future value. So given all this information, the question is asking how long can he keep on withdrawing 1350 each month. So that means n equals to what? But I want to make this clear here though. The withdrawal is coming at the beginning of each period, not at the end of each period. So how do we solve this kind of problem? Let's do this in Excel. So in this Excel file, I have listed all the information given. So the present value is 125,500. The APR is 9.25%, and this is monthly compounding. Therefore, number of compounding per year is 12. So we need to find rate first. Keep this in mind. Again, the rate is always equals to your APR over how many times the interest is compounded per year. So that's going to be our rate, and the payment is 1350, and at the end of the period the future value is going to be 0. And now we are asked what is number of year, meaning how long can Bernando withdraw money, for how many months, right? So that's why we use Excel's NPER function. So NPER, and now the rate we just computed, that rate, and here's a payment. So now whether this payment has to be positive or negative, keep this in mind, whether that money is coming to you or going out. So he's withdrawing that money, right? So that is positive, that's the payment is coming to him. So that's PMT, positive, right? What about the present value? Is that money is you are putting in the bank, which is an outflow, or it is coming to you? So you have to put that money in a bank to withdraw that 1350 every month, right? So that is going to be our negative value, and comma, and the future value is going to be 0, right? And one more information here. We most often do not use the last option, but sometimes we do use it. See here what it says, 0, which is the default. You don't specify anything. This is end of the period. But if the payment is coming at the beginning of the period, then you put 1. So that's how Excel handles whether the payment is being made at the beginning of the period or at the end of the period. And if you do that, that gives us for how long Bernando will be able to withdraw 1350, which is 161.7058 month. I hope that makes sense. Thank you.